In this video, we're going to look at the square root of 36m squared, and we're going to do our product rule for radicals backwards. So this is the same thing as the square root of 36 times the square root of m squared. The square root of 36 is 6, and the square root of m squared is m, and that's how we're going to get our answer of 6m. Now number 11, I've got the cubed root of x to the 6th, y to the 15th, so I'm going to try this again. The cubed root of x to the 6th times the cubed root of y to the 15th. The cubed root of x to the 6th is x squared from previous lessons, and the cubed root of y to the 15th is y to the 5th. So our answer would be x squared y to the 5th. Use a little bit of color here. Okay, number 12, see if you can try number 12 and then come back and take a look. Okay, number 12, you should have had the 4th root of 16 times the 4th root of x plus 2 to the 12th. And the 4th root of 16 is 2. And the 4th root of x plus 2 to the 12th is x plus 2 cubed. So we would have had 2 times the quantity x plus 2 cubed. Now number 13 doesn't have any variables, but we can also rewrite this looking for a perfect square. So look for a perfect square in the radicand. So what I'm talking about here is we've got the square root of 45. That's the same thing as the square root of 9 times the square root of 5. So that perfect square in the radicand is the 9. So try to look for a product that multiplies to be the radicand, but in that product, one of the factors is a perfect square. So the square root of 9, times the square root of 5 is going to give us 3 times the square root of 5. Now, this is just another way to do this problem. You can most certainly continue to break down 45 if you can't. If you're struggling to find the perfect square, I would not recommend doing, spending a lot of time doing it this new way, this other way to look at it. This way right here, breaking it down, will always work, and there's never a problem with you breaking down the radical. The square root of 200 is the same thing as the square root of 100 times 2. So that would become the square root of 100 times the square root of 2. And that's going to give us 10 times the square root of 2. Now, what this does is it really just allows us to do the math a little bit faster. So by doing the problems this new way, if you can see the perfect square, you can go straight from the square root of 200 to its simplified version of 10 times the square root of 2. Same thing here with the square root of 72. The square root of 72 has that 36 in it. So that's the same thing as 36 times 2. And the square root of 36 is 6, and then we'd have that 2 left over. So 6 times the square root of 2. Okay, see if you can do number 16. And then we'll talk about 17 through 21 because those are different indexes or indices. So the index is not a square root. We've got 3's and 4's in there. Okay, welcome back. The square root of 800 might be a little bit harder to see that perfect square, but if you can see it, if you can see 400 times 2 you would go straight to 20 times the square root of 2, because the square root of 400 is 20. Now 96, I'd have to think of my fourth powers. So I've got a 1 to the fourth, 2 to the fourth, 3 to the fourth, 4 to the fourth would be 256. So 96, maybe 96 is made up of 16 times something. 16 times 5, 16 times 6. It's 16 times 6. So this would be the fourth root of 16 times the fourth root of 6. And that's going to give us 2 times the fourth root of 6. But I will be extremely honest with you right now. I don't take the time to look for the perfect fourth power or fourth root. On this problem, will break it down. 2 goes into 96 48 times. 2 goes into 48 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. I'm looking for groups of 4. I would take that 2 to the outside, and then I've got this 2 times 3 is 6 left over. That would go on the inside. So I would most definitely break down these radicals. You go ahead and see if you can do 18, 19, 20, and 21. Press pause, and then come back and just check your answers. Okay, our answers for 18 would be 3 times the cubed root of 3. For number 19, we would have 3m times the cubed root of 3m squared. For number 20, we would have a 5x squared y cubed times the cubed root of 2x y squared on the inside of that radical. And on 21, we would have 2x cubed times the fourth root of 2. So if you've got those problems, give yourself a pat on the back. If you need help, please reach out for help. It's always there for those who ask. In the next video, we're going to continue multiplying our radicals. 22, 23, and 24, we will continue to multiply our radicals. And I'm going to throw a number 25 in there to help you on the homework. So on number 25, let's do the square root of 3 times the quantity, the square root of 2 minus the square root of 7. Okay, see you in the next video.